My name's Olly Nicholson, and I'm a field engineer at Unity. So I spend a bunch of time visiting customers that use Unity, learning about new features, and passing that information on to people like you. So welcome. There's my Twitter handle if you want to follow. So what's today all about? Well, I wanted to develop a 12-step program to turn your character into a player. What those steps involve are many, and those steps require that you go from the beginning of a workflow to the end of a workflow, which includes steps outside of Maya, outside of Unity, into Unity. And to give us an overview of that whole pipeline, I've produced a talk today to show you guys a live demo. So as I'm approaching my 40th birthday, it gets me thinking about life and mortality and things like that. So I decided to build a younger, toonier, sexier model of me. Let's think of it as donating my body to science in order to test this pipeline. So the kind of things that we want to think about when we've made a character that we want to bring into Maya, into Unity. That's my package of choice that I'll be switching to shortly, which is why I keep mentioning it. Working with characters in Unity involves a little bit of setup before you get to bringing a character to life. And those kind of steps I've divided into 12 sections. So kind of a beginning to end workflow that you guys can absorb, take away, and without doing any scripting or programming, come away from an empty, unrigged character mesh right the way through to a player. So let's call it 0 to hero, something like that. OK, so when you're working with a character model, there's lots of ways of generating that content. You might be working with a highly complex polymodeling, voxel-based solution, sculpting tools, character generators, 3D Studio, Maya, any of those digital content creation tools, and I may refer to them as DCCs from now on. They all have their own ways of creating very different models, some of which are suitable for real-time environments, some of which aren't. And of course, even within real-time environments, you have a huge variety of different platforms to target, from high-end PC right through to the lowest powered mobile device that you might be looking to. So it's very important to have a bit of a consideration for the target that you're aiming towards. And in that sense, you probably want to make your model look quite nice without 500,000 polygons, And some of the tools that you might use have built-in poly reduction strategies. They also just generate naturally thousands of polygons so that you can generate your high-res normal map from them. In that sense, it's quite good to think about using normal maps so you can add the extra detail that you don't have to retain in the polygon mesh. So prepare your model to look good without using too many polygons. Name your materials and textures sensibly. I'm going to switch over to Maya in a second, which is one of the examples I'm using to show character generation outside of Unity before you get to importing. And use, obviously, normal maps for extra detail where you can. Now, those can be generated in a number of different ways, by hand, in Photoshop, using various plugins, but also you can generate them from your high poly mesh using things like XNormal. You can load a high poly mesh with diffuse textures and then generate from that a lower poly mesh with normal maps and all those kind of things. And that's a very common workflow now for graphics artists. And not a particularly simple one, it has to be said, when you're working with physically based shading. But I'll touch on a few of these a bit later on. So you don't have polygon limits, obviously, but you need to understand that the more you use for your characters, then the less you have to spend on environment, effects, other characters, different parts of the game. You've got a sliding scale that you can adjust throughout your game production, which kind of helps you understand your budgets. 5 to 25,000 polys can be a good range to aim for a generic lead character, possibly. But again, it's dependent on platform. So don't go wildly under or wildly over, but at the same time, apply reason and sense to your models you're making. And then, of course, don't use polygons where you don't necessarily need them. If it doesn't show any advantage, you can make savings. So reduce polys with tools built into your DCCs. So Pro Optimizer in 3D Studio, for example, Poly Reduce in Maya, and then you've also got third-party tools like Simplygon, other places to look. And as you work, it can be beneficial to think about where your working textures live, your PSDs, your big file format images, versus where your output textures might be. And in that sense, it's quite good to have your textures located in your project in a pipeline you've designed to make them convenient on your project and a good size to work for your builds. So sometimes we have artists that create enormous PSDs living outside of the assets directory and then generate PNGs to go into their projects. So place them in assets, object name, textures if you can within Unity. The export pipeline does allow you to embed textures within your FBX. It just makes them a little bit less portable because they're enormous. If you've got big PSD files, that kind of thing, then you're embedding all that bitmap data into your FBX file or 3D file format. And in that case, if you have moved into your Unity project already, then repath them before you export so that your FBX is already pointing to them in the right place. And remember that your target is a real-time platform. We're going from a program which is designed sometimes to develop offline rendered content, and those budgets and constraints for a real-time platform might not always be referred to and considered before export. So have a think about that. So, for example, here in Maya, we've generated this character. You can see he's got a matching T-shirt, but I've failed to rip the arms off this one yet. Maybe later at the party. And so the thing about the model you've got here is that you're able to assign all your materials and your textures in Maya, and we have an export pipeline which will hopefully match up as many of your materials from the hypershader, such as your diffuse and your normal maps, into a standard shaded material inside your Unity project. So we'll go through the export process in a minute. But the crucial thing to think about is that if your character needs to be animated, then it has to be rigged. And rigging is kind of a dark art in many ways because there's very many different ways of doing it. Lots of people like to build their own bone structure from scratch. Some people like to use an auto-rigger on a website like Mixamo. Some people like to use some of the very decent rigging scripts that come in the major 3D packages. And today I'm just going to quickly talk through one example, which is in Maya, and that's called, if we go to rigging, we've got a very nice way of setting up characters called Quick Rig. There's also Human IK, which will allow you to actually generate a skeleton, scale it to match your model, and put the skeleton inside the empty model, and rig it and skin it and produce it all for you. The difference being with Quick Rig is it will actually allow you to generate markers based on your mesh. I'll show you that in a second. So from my presentation, moving on, I created a bit of a monster. Obviously, I'm not a character artist by trade, so it's one of my experiments in the last few weeks to generate a character. Did look a bit like the baddie from Thunderbirds. What you going to do? So rigging. It's important when you're rigging to prepare your model in a T-pose. So in order to bring the character to life in Unity, you basically have to understand that Unity wants to know how it will move when you bring it in to retarget your animation and do all that kind of stuff. Many characters you'll get on the asset store, they're already rigged and skinned, which means that some artist somewhere has made a decision about how different parts of that body move in reference to the bone system that's inside that character. So that involves building a skeleton and attaching influences to the vertices that surround those skeletons in order to move parts of the character like the muscles and the legs and create inverse kinematics so that you have knees that don't go the other way and all those kind of things that are standard for humanoids. So the three ways of rigging, as I said, you can create a bone hierarchy from scratch. I'm not going to teach the full rigging pipeline today because it doesn't really live in Unity, and it's not really my specialist area. I like to do things quick and dirty. I like to get stuff into Maya so I can have into Unity so I can actually have fun with it and escape from my 3D packages. You could use biped or cat in 3D Studio, obviously. Rigify in Blender is quite a good rigging solution for setting up your models to have a skinned rig, and in Human IK in Maya. And of course, the third solution, as I said, upload to an auto rigger. So you can grab an empty FBX that you've created, you can upload it to the Mixamo. I think you could create a login, and it will put in the markers for you that you can place and generate a nice starting point for an auto rig. So what's important to note here is that these are all starting points. Once you have an auto rig, it's likely that once you've imported your character into Unity and you've played about with the muscle definitions, and maybe you've played a few animations, that you notice some things might connect with other parts of the body, and you'll need to iterate on that and come back and improve how you paint the weights on the skin, all that kind of stuff. And that's a process that can take as long as you like in order to create the result that you want. The important point is that there's quick ways to get those set up in place so you're ready to iterate. For a bone hierarchy, if you are going to do it yourself, then create bones one by one in place for your skeleton. Obviously, you probably only need to do one half, and you can mirror things. So it's very important to understand about the implications of mirroring and negative scaling and resetting transforms for that kind of stuff. Hips should be the root element of your bone hierarchy in order for Mechanim, our animation system in Unity, to understand how to do root motion, all those kind of things like that. A minimum of 15 bones are required for a humanoid type rig, and possibly even a generic. And the difference between humanoid and generic is that at this stage, you can retarget humanoid. So it doesn't really matter if it doesn't look like a human. As long as it's got 2 legs, 2 arms, and a head, you generally can use a humanoid rig. Big fluffy teddy bears. There's a mouse in a demo that I've seen earlier. Once you've done that, the power of retargeting means that you can use any humanoid animation on any other humanoid character. And that opens up a huge library of animations to you guys. Rigging tools in digital content creation tools like Maya. I'm not Mayaist, I have to say. My background's actually 3D Studio. But when it comes to character stuff, it can be beneficial to try Maya because it's got some really great scripts they've developed for auto rigging. I've tried a bit of character work in Max, and I prefer using 3D Studio for architectural visualization stuff and modeling and engineering, and Maya seems a bit more friendly to animation and effects pipelines, but horses for courses, there's ways of doing it in both. So very quickly, in Maya, you can create a human IK, which is positioning the skeleton, as I explained before, and you can scale, move, and rotate bones that fit so that your skeleton is ready to apply a skinning algorithm to attach it to the skin. And you've got some really great binding calculations that you can take advantage of now, geodesic voxel being one of them, which basically uses voxels to control the influence of vertices on the bones that you're skinning them to. I'll very quickly go through these quick rigs. So if you've got access to Maya or any of these other solutions, you have an empty character, you can rig and skin it, ready to use in Unity. So in this particular instance, I'm going to select my all of the objects in my character mesh, and I'm going to go up to skin, and I'm going to, skeleton, and I'm going to quick rig. Now you can see it's highlighted in green because it's quite a new feature. Human IK is the other option, which is shown here, where you create a skeleton. You can create control rigs as well, but in that sense, we just want to then use the skin over there. But for the quick rig, we're going to have a go at this one. And there's 2 ways to try it. I quite like this step-by-step. That will allow you to add your character and see what's happening one step at a time. So first I'm going to add my geometry to this list, and I'm going to select the type of embed method, which means you can basically get a crack on finding out what goes wrong if it goes wrong by defining to Maya what type of mesh you've created. So we'll go with imperfect mesh at the moment. There's a resolution there as well. And at that point, I can do create and update, and it's going to put those markers in for me. So what it's doing at that stage is it's navigating the 3D character mesh, and it's placing some markers so that the next stage of inserting a skeleton, it means something to the package in order to understand where the best place to put the skeleton is. So the next stage, I've got some options here, my skeleton settings, mirrored behavior. There's also the option to go skeleton only. If I'm not going to be animating in Maya, there's no reason really to have a control rig there, because I want to be retargeting animations in Unity and making the most of all the stuff I can get from the asset store, or there's animations I've created previously for a character that I want to reuse. So I'm going to check skeleton only there. Then I'll do a create and update, and you can see quite quickly I've created a skeleton inside my mesh. And then the fifth stage is to choose how it was bound. So we're going to stick with the geodesic voxel version here, and let's see if that works. Yeah, OK. So just a quick test. I'm going to grab a bone, and I'm going to rotate it and go, yes, the arm moves. Brilliant. OK. Now, this is probably the stage at which we pause for about a month, and we fine-tune the rig that we've got, and we go in and we paint weights, and we do all this sort of great stuff to make sure that we've got a... But for the sake of 42 minutes, we're going to quickly skip on and export our mesh. And actually, even with this auto rig, it's pretty much ready to use with our character controllers in Unity. So going back to my presentation. So the other thing that Unity obviously supports is blend shapes. If you've got a bone-driven skeleton, bone-driven mesh in your animation pipeline, then you tend to focus that on walking and moving and locomotion animation type stuff. But if you want to do something like facial rigs and animating morph shapes, anything that can involve merging of lots of different target meshes into one thing. So phonemes is a common use case for blend shapes, where you generate a character in lots of different mouth shapes, and then you bring those phoneme shapes into Unity, and you can actually animate your character talking in Unity with a load of sliders. It's quite an exciting thing to do. So Unity supports blend shapes, and what that will essentially do is on top of your skeleton, it will create a series of targeted morph targets built into the FBX that you export. And those blend shapes will come across into Unity for you to animate with the animator. This is often, as I say, used for phonemes, talking faces. But the important thing is to decide which part of the character requires morphing, if you do need to do that. If you don't worry about it. Set it up in your digital content creation tools. And it's called blend shapes in Maya. There's a morph modifier in 3D Studio, and I think it's called shape keys in Blender, but correct me if I'm wrong. The other alternative, which I can highly recommend, is to enable in your third-party auto-rigger. Mixamo, it's not a plug because I don't work for them, but they do have a facial blend shapes tick button, which sets up a whole series of animations for just about every area of the face that you might want to animate, from opening the jaw to sort of winking, closing an eye, lifting an eyebrow, all that kind of stuff. And that will come out a nice, neat list that you'll see very shortly. So set those up in your package or enable them in your auto-rigger. Then we get onto the part where we want to verify and export. Now, in order to minimize errors and troubleshooting, it can be quite useful to take what you've exported, and before just dropping it straight into Unity and creating a load of materials and wondering why he's doing this or that and the other, to understand what you've exported and why, it's quite handy to bring that FBX back into Maya first, or whichever package you've used to export it, to verify that it's what you expected. Because it's very easy to drop it in Unity and go, oh, it doesn't look right, I can't work out what's wrong with Unity, fire a bug report off and blah, blah, blah. But it might have been a setting you didn't check in your exporter. It might be a scale thing that you didn't have set up in your source package. But the process of bringing that model back into Maya, Max, Blender, Modo, whatever you use, will actually show you what you exported rather than what you think you've exported. So that's one verification top tip that I have, especially if you're handing an asset off to an employer or a contractor or somebody that wants to take the work that you've done. It's really good to verify that stuff. So part of that verification process in a modeler, for me, is to remove anything that you don't want to be exporting. I mean, that sounds obvious, but the amount of things where you just go to export rather than export selected or export all, and you forgot that you've hidden a whole bunch of guides, or there's another character doing something funny in the background. There's some cameras, which we can import, by the way, now. Cameras now important to Unity. Anyway, but you didn't want them in your character file, really. You want those as a standalone. So remove unused meshes, extraneous assets like lights and cameras from your scene. And if you want to take a shortcut, just use the export selected if your 3D package is allowed. But then, of course, make sure you select what you want to export. It sounds obvious, but sometimes you might have a control rig that you didn't know was there that you've actually selected as well, or you haven't expanded the hierarchy enough. And although, we've got a very close partnership with Autodesk, we're not Autodesk, we still recommend the FBX file format because it allows for greater file portability and simplicity. If you think of the FBX pipeline as a bit like a fat pipe that you can throw anything through, well, most things, vertices, quads, different types of textures you can put in there, you can put attributes, you can put information about, all that kind of stuff is all well and good, but it's only as good as the connections either side of it. And obviously, Autodesk, in that case, has taken care of the connections on Maya and Max. Other third-party DCCs like Modo and Blender have made efforts to connect with FBX as well. And we are making increasing efforts and working closely with Autodesk in order that we can ensure what comes out of that FBX pipe, or that container of data, is neatly matched to as many of the things that you want to set up straight away in Unity as possible. So we're talking about materials, going straight into the standard shader with your texture slots populated. We're talking about scales, and we're talking about extra types of things that we're supporting now. Talking of which, we now support import of cameras and lights, as I said, but we also support the import of an object's visibility when it's animated. So previously, you could set keyframes on an object in 3D Studio, its visibility as a checkbox, and you can turn it on and off as you animate. And that information was useless to Unity at that point. But we now use that to import, and it will turn on and off the mesh renderer for you. That's just another simpler way of playing with it. We've also improved the way that we import normals, so that you have angle-weighted and area-weighted normals, which makes the calculations at import time in Unity look much better. Basically, there's two ways. One's optimized for low poly meshes, one's for others. But they use much more information about the mesh to calculate the normals better. And that's under the object I'll show you shortly. So if you have your own animation clips, of course, check the animation checkbox in the export dialog. Sounds pretty obvious, but when you're animating your characters in your third-party package, your motion builder, your Maya, whatever you use, there's a number of different ways to import animation. This talk is actually going to focus on repurposing existing animations you may have already done. It's not an animation workshop outside of Unity. So if you've got your own clips, check the box when you export them from your package, or verify, obviously, your model by re-importing it into your DCC. Importing your model. So before we do that, let's actually just go ahead and export so that we can see what we're doing. I'm going to just do the classic select all. export all in this case. And I'm going to take a bit of a risk here, and I'm just going to completely start a new project from scratch, because that's kind of how I roll. I want to and of course, a really sensible naming convention for a new Unity project would be to call it New Unity Project. So I'm just going to remove the spaces, so it's camel case. And we've got a very sensible, I'm being sarcastic, by the way. Please don't use the word new. Let's say DCC Unity character to player. See, that's another lesson in naming convention. Don't use lots of letters that nobody will understand. So let's call it char to player. That'll do. Create project. Obviously, when you create a project, it puts a bunch of things on disks and creates a few basic folders for you. So with an empty scene, you obviously have a few folders that you could start to create, the first of which I might just call models as a sensible place to put my models. And if you remember before, I talked about locating all your textures into the project. I'm still a bit of a stickler for that. I like to know where all my things are. So from my desktop, I've got here's one I prepared earlier, folder of textures. And I'm going to nest that inside my Unity project. I love alt-tabbing. OK, so drag that onto there. And so what that's doing is it's adding all the textures that I've already pointed to from Maya. I'm just going to make sure that they're all in there. And even though Maya doesn't know the full path name to get to those textures, it knows to look for the, well, Unity knows to look for the textures at import time if they are nested underneath the object that you've imported. I hope. Let's hope it all works out this time. So let's find our new project, Unity projects, char to player, assets, models. OK, so within the models folder, this is where we take a look at the export options, and that there are many. One of the crucial ones, actually, is which version of FBX you're using. For the hell of it, I'm just going to go with the latest, because, you know, why not? Then there's a bunch of things to do with what you include, what kind of scales and bits and bobs you are working with. So you might want to include, exclude, or enable some of these things to convert complex meshes that you have at export time, so that you don't have to bake them down to a certain polygon or this kind of stuff. So there are things you can do at export time to preserve your non-destructive workflows. In that case, we are going to enable animation, although we haven't actually got an animation here, so actually let's not enable animation. We're going to not bake stuff. We're going to just check through. We haven't got any lights and cameras, but they do work now. And crucially, I'm not going to embed media at this time. That's quite useful for handing over an asset to somebody that has a project that needs to require it, because it will spit out a materials folder for you when you've imported into Unity, and it will give you the opportunity to set those materials up at import time. But it gives that user that you're passing it over to access to all the textures, rather than, oh, I've got all these lost textures. Units, there are scaling factors that you can apply. Try and leave it on default, and then if it doesn't work, then you know where to start fiddling. And if in doubt, add a cube. So I'm exporting a binary format, and I think that's about everything. The only thing now is to come up with a really sensible name for it. So let's just call it me. Check I don't get a million warnings. And then if I switch over to Unity, I'm hoping very much that we will have a model of the younger, sexier, toonier me. There we go. So it's very shiny. I am very shiny, but I don't need to be that shiny. So the first thing you'll notice, I'm just going to switch back to my presentation. When you're importing your model, you should be able to just drag that FBX, because as soon as you've exported it, Unity populates the project with the file that you've generated, and it generates the materials. Now, you can choose how to generate those materials based on either the texture name that it understands from the FBX file, or the material name. And that's quite important because it determines how many iterations of that model you can bring in without constantly creating new materials. So have a think about that. But to start off with, it will just import and create some materials for you. So you can select your model in the project browser and set the options in the inspector panel. So this is where we have a little look at what's going on at import time. We've got three tabs here: model, rig, and animations. For this one, it's only applicable, the model and rig are the only tabs that are applicable because we haven't actually exported any animations there. So the options, I don't know if you can see that very well. It's quite small on that screen. Andy did this cool zoom into the screen thing that I think only people with Apple Macs can do. So I'm just going to read them through one at a time. The first is the scale factor, and that basically enables you to adjust the scale of that object at import time without having to change transforms in your scene file or your project and have all sorts of stuff go wrong with it. So that's kind of like an override for the file on disk scale, which you can adjust if it comes in the wrong size from the 3D package and you don't have access to that 3D package. That reminds me why FBX is a good file format, because if you export a Maya file or a Max file and your end user doesn't have Maya or Max on their machine, then you're a bit stuck, because the process of converting those ready for use in Unity is to actually launch a headless version of 3D Studio or Maya in the background and use the FBX conversion process in the background. So it's another reason why FBX is a bit more of a portable file format that you guys want to try and stick with if you can. You have mesh compression options here, which basically welds a few verts behind the scene, does a bunch of stuff to optimize your meshes. For animation, I'm going to leave it off for now because it can have some issues with skinning if done incorrectly. But we've also got read and write enabled. Optimize mesh is a way of optimizing the higher. I think it sounds similar to mesh compression, but it's actually a different thing that I've written down somewhere that I'll be able to tell you, or when you come and get a card from me and remind me. Generate colliders will allow you to generate a set of colliders around the mesh, which may be quite expensive if they're mesh colliders to surround a complex shape. It can sometimes be better to generate your own. For this example, when we create the player, we're going to create a capsule collider, which means that your character walks around with the physics presence of a capsule instead of the physics presence of something a lot more complex. Obviously, later on, you can add more and more colliders and do more and more important things with those. Weld vertices kind of does that behind the scenes so that you have watertight mesh. Import visibility, that's the new animate visibility function so that you can enable and disable the mesh renderer from animation. And import cameras and lights. Swapping UV channels, so you can have, if your UV channels are generated in 0 or 1, and you can switch them around, which can help if you're wanting to reserve a channel for light mapping, for example. And then, as explained before, the new normals and tangents. The safest bet is to author them yourself in a third-party tool. You might use smoothing groups in 3D Studio. You might have hard edges that you select individually. And how your mesh looks in the source package is generally the gospel. It's what you want to preserve. So you just use import. If, however, it doesn't look right, or you've got the asset from someone else, or nobody's applied any, you now have lots and lots of options, more than before, in order that you can make the mesh look the way you hope it would look if it was imported with some nice normals from Maya or Max. And the smoothing angle is what allows you to calculate that. We're going to leave that import at the moment. So once you've got those settings, you can apply. I'm going to then drag this into my hierarchy. Of course, dragging it into the hierarchy puts it on 0, 0, 0, rather than dragging it into the scene, which puts it on there. the first thing I notice is that it's backlit. So I'm going to switch the default light around so I can kind of illuminate my character. So the next stage is to try and understand why it looks like it's wrapped in a plastic bag. And that's generally because the way the materials have imported, you need to do a bit of setting up of those materials inside Unity to get the best of what you intended to import. So, for example, if I find my materials here, I can select my mesh, and the first thing I notice here is that I've imported an albedo or a diffuse, which is fine. But the type of shading here, I've wanted to generate as a specular setup. And that means that I generate a map for the specularity of the model rather than a metallic map. So I'm going to switch to that. Also, that means that I need to create a material, or sorry, a texture, which contains a gloss and specular in the same file. So we have the specular in the diffuse, and we have the gloss in the alpha channel of that. So we need to switch that out for a file which I've prepared already, which would help stop the vest looking shiny, because in my source package where I've developed my character, I've got maps for all of those. But if you've got a character generator, or if you're coming from another package, you tend to end up with separate maps for all of these. And what you actually need to do for the standard shader to work the way you want it to, is to combine the specular and gloss into one map, which also saves on a bit of disk space, so it's no bad thing. So I'm going to pick me body SG, and that has the information about the specular and smoothness or roughness of the character. So I also have a slider to amplify that, so I'm going to drop that right down to kind of go towards a t-shirt material. The next thing, obviously, we'll notice is the skin. And in an ideal world, we will pick a skin shader. This is a kind of toony character, so I'm not going for full-on photorealism. And you can get a not bad skin with the default standard specular workflow if you don't worry too much about subsurface scattering. So obviously, I'm going to drop the... going to move the light. And lighting's quite crucial as well, to kind of see what you're doing. Nobody really wants a backlit character. So I will... Dude looks like a lady. I'm going to have to play that song at some point. So we're going to make some adjustments here to take off the shininess. There's a load of stuff you can go on with the materials. The whole physically based shading workflow, it would be a whole talk on its own. But for this, we're just talking about getting a few materials set up, kind of how we want them, and then moving on to bring the character to life before we run out of time. So, next stage, there's a very quick material here that we're going to also switch out. And I might want to maybe darken them a little bit to my... What do you think? Oh, no, they've kind of faded in the wash. I'll leave it quite light there. But did you notice the Unity logo? I need to get one of those for my shorts. Well, that's the advantage of having a digital version of yourself. You can make it better. OK, so I've played about with the materials a little bit. Once I've done that, check my list of things that I've done. I've switched to the standard shader, which I've done, and I've pasted the gloss into the alpha channel of the specular and created a targa or a PSD. Selected that new one. Adjust the normal maps. So again, you've got the ability to add wrinkles by upping the amount of normal map that's here. So we can make super old. Obviously, it's got to be subtle, because otherwise it just isn't going to look like skin. But I've just wanted to reassure you all that I wasn't trying to make myself look totally youthful. You know, there's a few crow's feet and whatever. So, moving swiftly on. Creating an avatar. Now, this stage will map your skeleton to an avatar to use with any humanoid animation. And this is all about the rig tab. And the rig tab will allow you to specify some different types of rigs. So we're going to choose humanoid for the animation type and click apply. And then we're going to configure and observe the skeleton mapping and muscles that it does. So if we switch back here, This is important. You need to select the object on disk, not in your project folder, not in the hierarchy, because obviously that doesn't have these settings. And then under rig, I'm going to create a humanoid one. And before I do anything else, I'm going to click apply. When I configure it, it'll ask me if I want to save the scene. Yes, I will. So I'll give it a really funky name, like, we'll call it me player, something like that. Because it launches this scene, which allows you to configure the muscles and have a look at the mapping for your avatar. Now, it's quite complicated, except that you don't actually need to do much if it's all in green. So if you're not that concerned by it all, just click done. But I will show you that you can then test your rigging by having a look at all of these options, do some crazy exercises. These are all the different extremities of movement that you might have for your character, and they will reveal the kind of problems that you have with your skinning, if there are any, once you've skinned your character. Like one polygon, a vert that's actually closer to a bone here, suddenly pulling through the skin. There's lots of things that can happen at this stage. And this is the kind of process, this is the reason you want to get your riggers involved in using Unity as much as possible. They can see it, they can preview it, they can try stuff out, and make sure that they're getting the result that they want. Right, moving swiftly on. So once we've done that, we can click done, and we're good to go. Test your skinning, that kind of stuff. We now have a character, which is kind of rigged, but obviously we need to bring it to life. So two ways to do that. You can either hire a talented scripter to write you a load of controllers for your character, or here's one we prepared earlier. That's we being Unity. You can import the standard assets character controllers. So what I'm going to do here is I'm going to pick characters from there. And that's going to bring in everything I need to bring the character to life. It will already come attached with its own character, which we're going to remove and add our own very quickly. Then at that point, we can bring in a camera, and we can have a free look cam, and then we can start wandering around with our character in the game. So one thing that I quite like to do at this time of day is to create a plane on the origin, because then we've got something to walk on. So while we're here, let's create a plane. It's not on the origin. Why is that? So we go 0, 0, 0. So we have something to walk on. We look for our standard assets, characters, and we're going to go to our third-person character prefab, and we're going to drag in the third-person character prefab here. So the first thing you'll notice is he's a little bit shorter than me. That's not a problem. And the process here is to simply drag me onto that controller, because that controller contains all the scripts that I need for the character. So I then am going to disable the existing one that was in there. I'll probably delete it eventually anyway, but I'm just going to remove all that kind of stuff. And then from the controller, I need to switch the avatar to the avatar that I just created, which is the me avatar. So what have I got? I've got essentially an empty parent node, which has all the scripts I need already set up. It has a rigid body, it has a capsule collider, and a third-person user controller. And more importantly, it has an animator, which has all of the movement associated with a humanoid character, including a complex blend tree that will switch your animations between walk and run, but also different variations of left and right locomotions. I'll explain a bit more about that shortly. So if I push play, we might be in luck and see the character moving. OK, so the idle is playing. The next step would be to import a camera that we can use to follow the character around the scene and get a bit closer to the action. So again, something we prepared earlier, import, package, and this is called cameras, surprisingly enough. So that's all the camera stuff that we need. We are importing those. And then if we look in our cameras, we can find a prefab called the free look camera rig. So I'm going to drag that in. One of the things I'm going to do is to assign a target. So at the moment, that's called third-person controller. Should we call it me instead? And then we're going to drag that onto the target. Oh, we need to reselect that. Drag me onto the target of my... So that it's going to focus on the transform there. And then we are also going to have a look at the main camera is currently set here to be -4 meters away from the character. Let's drop that to -3. And you can see that comes a bit closer here. Then if we press play, what's next? We haven't disabled the default main camera. So we can delete that or we can disable it, whichever you like. Let's maximize on play so we can see it a bit better. And the crucial thing to note here is that you have a character moving around your scene, walking on the ground from an empty character skin right through to a player. Thank you very much. No, there's a few more things to do. So the first thing you'll notice is that the character's moving around, but to be honest, he doesn't really look like he's had a night out at the Unity party. So why don't we grab a couple of zombie animations and make it a bit more like how I'm going to look tomorrow in order that we can understand the animator and what goes on here. So we have our blend tree, and within the blend tree, we have this brilliant graph which basically decides, based on input, which animations to play. And this is all set up for you. And as you can see, there's different motions that represent different parts of the blend tree. And there's different parameters that you can edit. For this, we've obviously got an idle for when the character is in idle state. And we've got a walk, and we've got a run, and we've got all of these different humanoid walk, and all the variations in between the extremities of, say, pushing right to the left of the joystick or running at top speed. And all of those can be controlled in the animator using one of these. You can see this is all on the base layer. So the first thing I'm going to do is to go and find my zombie animations. So I'm going to drag this whole folder into my assets. And once I have a look in those, I need to set those up to use the same avatar. And what we have here is a zombie idle, a zombie run, and a zombie walk. So the first thing I'll do real quick is from the rig, I need to select that as humanoid so that it can be retargeted. And rather than create from this model, I'm going to copy from the avatar that I've created because I know that it uses the same skeleton. So I'm going to apply that there. There's a few errors on the rig tab. Oh, let me just create from this one first. This is the way I fixed it last time. And then just configure, save our scene as we go along. That looks OK to me. And then I'm going to copy from another avatar. So me avatar, update, apply. Oh, it's got an error on that one. Let's have a look. It's a slightly different. So let's just use its own. In this instance, that's fine. Create from this model. And we're good to go. So that hopefully should be able to play there's our idle, that's working. So the other things that we want to do with the animations, to set them up real quick, is to make sure that they loop so that the idle will be looping. And we're going to bake into pose the root transform rotation and the root transform position. And we're going to set that to feet so that we can use these animations and repurpose them. And we're going to do the same with the run and the walk. So let's have a little look at these. We're going to return to the inspector, the rig. I'm going to grab this one. Create from this model, apply. And we're going to whisk through that one, done. And finally, this one, humanoid. Humanoid, picture model, apply, and done. So hopefully now, when we can add those, we should have a... yeah, that'll be me tomorrow. It might be even me later on tonight, to be honest. Let's just reapply the other bits and bobs we need. Look, that looks like it's all done. So here in my animator, I've got these, which can be replaced. So I'm going to put in the zombie idle, which is here. Plonk. Oops, I'll do that again. Zombie idle. And then we're going to put in the run and replace the run down here. And there's a walk as well at the bottom, humanoid walk. So fingers crossed. And yeah, he's already looking a little bit worse for wear. So this is my state of mind, physicality tomorrow. Ooh, yeah, great. OK, so happy with that. So I've replaced some animations for my own, well, from some other animations that I've sourced. The next thing would be to set up some blend shapes. We can grab a model that we previously had. I've got a character model here. So let's have a look. Me ready. We're going to drop that one in. So the crucial thing about setting up the blend shapes is to add a layer so that you can have an additive result without affecting the underlying animations. So we have this character here. We're going to do the usual bits and bobs in the inspector, set up the rig, humanoid, apply. I will just adjust here so you can see it all a bit better. And the next stage will be to then identify and animate those from here. So we've created the avatar, we've tested the skinning, and we've added our controller and camera. So adding the animations is pretty straightforward if you've already got a blend tree set up there. Obviously, you can do it from scratch and create the transitions that you need. So adding the blend shapes, we're going to add a layer in here to this. So we've got our character here. I'm going to drag this new one with the blend shapes applied. And again, we just do the old trick of dragging me under there and disabling me or deleting the old one. So that's got the old materials as well, but we can reapply those shortly. So let's just check if that works. We have me, and we need to update the avatar to the new one. And then hopefully if we press play, yes, still got the zombie animations. Happy with that. The next stage would be in the animator here, if you can see that. I'm going to add a layer, and I'm going to call that, I'd probably be gurning in the morning or yawning or something. Let's call it yawn. And I'm going to make that layer to have an additive effect. And I'm going to put the weight up to 1, otherwise I actually won't see the effect. So the next thing would be to very quickly create a blend shape animation from the blend shapes. And what you can see here, when you select the object and you actually go to the body, you'll see, let's just scroll down here, we should have blend shapes. So suddenly, I open up the blend shapes there, and I have all of these animatable parameters that I'm able to adjust in slider form so that I can put an animation on the animation pane and set keyframes for these kind of things. So the first thing I would do is to go to the animation tab. And when this is selected, I need to create an animation. So I'm going to go back into my asset animations, and we're going to do a yawning animation. And at this point, I can very quickly show the new animation keyframing workflow, which means that when you start to work with creating keyframes, it no longer sets to an auto key the red record mode by default. You have to turn that on because you can manually set keyframes now from a contextual menu. So once I want to set a keyframe for one of these, let's have a look. We're going to try and open the drawer. I'm going to zoom in here. Let's just really quickly assign the right body material again, so it's not all shiny. And a me top. There we go, that's looking a bit better. And what we're going to do is have a look, see if we can actually move some of these. So if we go draw down, it starts to actually animate based on the blend shapes that have been imported. There's not a lot going on inside there, but then I probably would have had a few drinks, and I've just turned into a hollow entity. So 100 is essentially 100% of that blend shape. So I might want to set a keyframe on that. And this shows us in the new workflow for animating somewhere, if I can. I might have to set the first keyframe in auto mode. So I've got a keyframe here, and I'm going to set that to 0. So I have a keyframe. Then I'm going to come out of that auto mode, and I'm going to move to, say, here. Now, it does something quite funny because it's a rigged setup. But once I bring that up to 100 again, so it's fully open, it'll ask me if I want to add a key here. So I can do that manually. So I can add a key, and it will keyframe that for me rather than auto-keying it. So I can see very quickly that it's added a quick blend shape, and I'm going to maybe Control-C, Control-Paste that one. So I've got the kind of yawning, gurning stuff going on. And then that animation clip, I go into my animator, and I'm going to find the clip from my animations here, and it should be called Yawn. So I drag that into there, and at that point, it should be playing my yawn over the top on this layer as I walk about as a character, if we're really lucky. Yeah, it's yawning of sorts. Let's have a look. If we turn off the maximize on play, we should be able to have a look at where that's going. So if I make a transition back, I might have to create a state first to put that animation into. So I'm going to break that link there. Okay, and then drag in yawn. Make a transition to it and one back so it finishes. And then we should be able to have some gurning going on in here. Very nice. Now, I'm running out of time, so I'm going to very quickly move towards the last section. So adding environment lights and effects, and this will be really very quick because I've got about 1.5 minutes left. So if I open a scene where I've got that stuff already set up, and in this example, the lighting apartment demo, we can see dropping the character in obviously makes a lot more sense when it's in the context of an environment and a nice lighting setup. So even with a toony character that has a series of physically based shader properties that may not be like totally reflective of a photoreal environment, even dropping one in will give a nice feeling to having the character ready to play. So I'm just going to drop that in, see if I've got my prefabs there. Animations, standard assets. So let's have a quick look. Scenes. Import a package that I've created. And from my downloads, I can grab this package. There's me, prefabs. Drop that in here, and if we're lucky, we have a character ready to play. Obviously, it'd take a bit of placing around the environment. I need to put the camera in to set up as the target. So I grab my cameras, and I'm going to grab that from the standard assets, my free look camera rig, and quickly target it to the transform of me. We should be just about ready to go. Fingers crossed. There's a character. Just disable the other cameras, which are turned off. Free look camera rig. There's already one there, I see. So I'm going to disable that one. My bad. And we have finally to add my transform to there. And hopefully, hey presto. Yeah, we have character walking around like a zombie in an apartment, ready to destroy it after a big night at the Unity party. Thank you very much.